Okay, hi everyone. So we are going to have a little chat about the top 10 best new features of C# version 6 to 9. So my name is Chris Klug. I work at a company called Active Solution in Stockholm, where we do custom software development on the .NET platform. And I do a lot of speaking engagements at conferences as well. So I have a weird role where I talk about things and explain things that I've learned along the way, which is kind of cool. So I sat down, I was looking at doing conference talks during COVID, and I was like, I want to do a talk about the best C# features, because there's so much cool stuff that has come out lately. And I thought a talk about that would be not what I normally talk about, but it would be kind of cool. What are the best things? So I thought, hey, let's do a top 3 best features. And then I was like, no, it's more like a lightning talk, pretty short. It's hard to do 3 features for an hour. So I went like, let's do top 5. Top 5 best C# features, sounds about right. And then I pulled up the slides, I pulled up the interwebs and looked at what features had come out. And I was like, oh, no, there's so much stuff going on in the C# world that 10. I definitely need at least 10 not to fill out my hour, but actually cram 10 into that hour, because I need to show off at least 10 new features because there's so much cool stuff going on. So here it is. My version of the top 10 best new features in C# version 6 to 9. Before I get started on the actual C# features, I just want to mention a few little things, or rather one thing in particular, and that's default language versions. So depending on what version of your framework, and what framework, to be perfectly honest, if you're on .NET Framework, or if you're on .NET Standard, or if you're on .NET Core, or if you're on .NET 5, there are different default language versions. So if you're on .NET Framework, you end up with 7.3, C# 7.3 as the default version for that language, for that platform. And for .NET Standard, same thing for 1 and 2, because they're compatible with .NET Framework, so that's 7.3 as well. 2.1, it's C# 8, .NET Core 2 is 7.3, .NET 3, 8.0, and then on .NET 5, you obviously get the latest and the greatest, and you get all the new features, so you get C# 9. But if you're on these platforms, it might be interesting to switch anyway. So you can actually go into, if you're on .NET Framework, you can actually go in and change version of the language by setting up an override in your CS proj file. One thing to note, if you go into an older project and you change it up to the latest version and say, hey, I'm going to use C# 9 features, woo! Some of the features will work without a problem. Some of them won't. So some of the features in C# are just syntactical sugar that works even if you're on an older platform. But there are features in C# later versions that actually require runtime changes, which means that you cannot run them on previous versions. So if you're going on .NET Framework, for example, and you go in and you change the C# version, make sure you know what stuff that you can use. I do believe that the compiler would tell you that this is not going to work, but some features will, some won't. Just good to know. So okay, let's just move on from this and have a look at top 10 best new features in C# version 6 to 9. And in no particular order, number 10, string interpolation. So string interpolation is something that we do a lot, right? We write stuff like that. So we go and write property plus double quotes, space, double quotes plus blah, blah, blah. And it becomes a bit hard to read. There's a lot of plus signs, and there's quotes, and you have to figure out what quotes to use. It's a bit of a pain, right? And also, this is actually performance-wise not that awesome, because it's actually going to create a bunch of middle strings and stuff like that. So it's ugly. That's the main thing. And then somebody comes and says, hey, let's do string.format instead, which is way nicer in one way, because you get a template-based string instead. So you get your string, you put in your templates, and it basically says 0, 1, 2, 3, and then you put in the values that should be shoved into those positions, and you're good to go. Bit harder to read, bit harder to figure out, especially if you happen to work with some nutcase at your office that goes ahead and does that. if you start moving around the order of things, it becomes really hard to read. So you kind of end up with this, so 1 actually is first name, and 2 is last name, and then 0 is name, and then the date at the end. Okay. If you're going to use string.format, don't do that, please. It's really hard to read. But if you're on C#6 or higher, and C#6, we're talking really old stuff. So C#6 works on everything that you're writing. You can just go ahead and use this string interpolation syntax like this, which is much nicer. Just prefix your string with a $sign, and then inside of your string, you just put your curly braces, and then inside of your curly braces, you can put C#, and whatever that string that C# outputs, it gets interpolated into your string. This is it's backwards compatible because honestly, it's just syntactical sugar. This gets turned into a string.format in the end anyway, but it's just so much easier to read because it's literally, you can look at it and go, okay, so it's a first name, last name, posted in, group name, on, and then the date. Very simple. So that's number 10. At number 9, we have default interface methods. So default interface methods are interesting, and the idea behind them is this. You build this beautiful interface. Email client has one method called send email. It takes a to and a from and a to and a subject and a body, and then it sends an email. Very nice, very simple, works perfectly, no problems at all. And then you get into that planning meeting, and in that planning meeting, somebody says, shouldn't we use templates for the emails? Because, we're going to have them in different languages, and we're going to have to do replacements and all of that. Wouldn't it be nicer if we had templates? And you sit there as a developer going, oh, okay. Yeah, okay, well, we can do that. So you go back to your interface and you write this new method. You add this method to the interface saying send templated email instead. And it changes because it doesn't have a subject and a body. Instead, it has an email template, and it has a dictionary with replacements. So you can replace stuff inside of the template. All of that, very nice. No problems at all. I'm happy with that interface. No problems at all. Control-Shift-B, build the solution, and you get that. You get an error. And the error is email client does not implement interface. And that's because there's already an implementation of your interface. There's already an email client that implements email client. And now that you've changed the interface, you're forcing that email client to implement that method as well. And if you don't, well, in this case, it's probably going to be your internal client or your internal implementation. So that's not a problem. You just go and you can implement it there. But say that you add these things to things that you put on NuGet, and you have to force people to implement new things, for example. Bit of a hassle. So in C#8, what they did is they said, well, let's allow you to put a default implementation on your interface. So what we do here is, you can see we still have that email client interface, and we have the new method, the send templated email, as we normally we had before that I just added. But normally you'd end there and you wouldn't have an implementation. But with this new default implementation, you can go and you can actually add an implementation to your interface and say, okay, so if you implement this interface and you don't implement this specific version or this specific method, we will give you a default implementation. There are some limitations to this, obviously. So the implementation that you're giving, the default implementation of that method, can only use things that it knows is available. So in this case, it can use the send email method from its own interface because it knows that I am a default implementation for this interface. So whatever class that implements this interface will have implemented the send email method as well. So I can use that. And then you can obviously use all the input parameters and so on. But you're limited to what you've got in the interface for quite obvious reasons, because that's all you have to work with. And then when you build this, it means that the person implementing email client only has to implement send email, and then it can accept, he or she can accept the default implementation of send templated emails until he or she decides to implement their own version of it. So that's kind of cool. Gives us a bit of a sort of a fallback, backwards compatibility situation where I need to unuse stuff. but I don't want to force everybody to have to change a bunch of things, so I can add a default implementation, which is kind of cool. It actually means that we can change an interface without it being a breaking change. So you don't need to do a major version upgrade. You can actually add an interface that doesn't break anything. It will keep working. Okay, default implementations. At number 8, we have out variables. Out variables is a tiny little thing, and it just fixes a thing that I really hate. So this is the way that we got out parameters in C# before, right? You'd have to create your int value, so your little member that would hold the value, and then you do like a try parse, and then you do out, and you'd pass in the value, and then if it succeeded, the value field here would contain the value. Otherwise, who knows what it would contain? And to me, I hate that thing. It messes with my OCD or CDO because it's annoying. I don't want to have to declare that thing first. It's just ugly. So in C#7, they decided to actually fix that. So in C#7, they told us that, hey, how about we let you do this instead? So they allow us to go and say out int value. So we don't have to declare the variable first and then pass it in as an out parameter. We can actually declare the variable at the same place, and then after that if statement, or after the try parse, the var value will actually be assigned, or sorry, the int value will be assigned. So just nice extra thing. And also I just let the cat out of the bag, but you can also switch the out int to an out var to have it automatically typed. So this is nice. It removes those extra. We're still going to need the variable, don't get me wrong, it's still there, but it means that we don't have to have that little extra one-liner above the try parse where we define the value. We can just do it as part of the try parse. Really nice little tiny addition, but it's definitely worth having a look at and using. At number 7, expression-bodied members. So expression-bodied members, they're a bit more complex. As you can see here, it's high and low, right? My top 10 list is everything from really complex big features to, hey, I can move the var assignment in an out parameter to the method call. There's going to be a big and small pieces. Expression-bodied members is a medium-sized piece, and it's kind of interesting because it gets added to a bunch of other features as well, and it allows us to do other things with the feature than what I'm going to show you here, but this is the foundation. So imagine that you have this class here, right, the product class, and it has this get for the properties, and we have to have a backend field for it, and we have to have a get accessor, which just returns name, which honestly, it's quite a lot of code for just a simple thing like having a read-only property. And yes, we've had this thing for a while where we can basically say we can remove the backing field, and then we can have a private set on the properties, which isn't actually really the same thing. But it works in the same way. And we remove the backing field, and we get a read-only property. It's nicer. Still lots of curly braces and stuff. So in C#6, they added this feature of expression-bodied members. So it allows us to go and use these arrow functions where we still have the backing field, not getting rid of that right now, but it allows us to do a very short one-liner, say, here's a property, and when you call that, you're going to get the, in this case, underscore name or underscore price. So our properties, our get-only properties becomes these really nice, simple, tiny things that we can write on one line without a bunch of curly braces. However, as soon as you go from read-only to read-write, you are back to this syntax here again because, well, either that or you can use that other syntax with get semicolon, set semicolon, and remove the backing field. But you still end up with a bit more code. So in C#7, they've taken this code here and turned that into expression-bodied members as well. So not only for read-only properties, we can actually in C#7 go and do it for both the get and the set as well. So once again, we get rid of some curly braces. Not a huge gain, to be perfectly honest. It's just kind of cool. And as I said, Expression-Bodied Members is a medium-sized function. There's a lot of stuff going into it, or feature. And what I'm showing you here are some simple examples, but it actually permeates the language in a lot of places where you can do a lot of more things with this feature. For example, you can also go and change functions, right? So if we have this toString function here, which is it becomes 3 lines. I know it's not a big deal, but it becomes 3 lines, curly braces, parentheses, return, and blah, blah, blah. In C#6, we can change that into a nice one-liner again, because all we want to do is do a bit of string concatenation and return that. Why do we need curly braces and return and all of that? This just becomes a nice, simple terse syntax for doing that same thing. And with C#7, they've taken it one step further and actually allow us to do constructors and destructors or finalizers with expression-bodied members as well. So once again, we save a few little curly braces, but honestly, it's for the constructor and finalizers or destructors. I don't see it being a huge deal because it only works for pretty much for constructors with 1 argument, and often we have a few more. And for the destructor, we often do a bit more than just log product was finalized, to be perfectly honest. So that was number 7, expression-bodied members, which is kind of cool. We're going fast, I know, but there's quite a lot to cover. So at number 6, we're looking at discards. So discards are interesting because, well, they are more of a intent thing in a lot of cases. It shows your intent with your code and not actually that much of functionality. So if we go in and we have a look at this code here. So we have do something that returns task, and do something calls do something else that also returns a task. And we have this await statement here, but as you can see, do something else actually returns a string. So the question is, that line there, did the developer here sort of forget what was coming back? Or was this intentionally leaving the return value out there? And also, if there is a return value, why is it not being used? There has to be something weird going on in here. And it can be a bit sort of, it's not a big problem. It's just, it looks weird. Because it's like, there's a return value, but you're ignoring it. Was that intentionally? So in C#7, they introduced discards. So discards is the idea where you have an underscore only. So you declare a variable, or you declare just underscore. Underscore equals await, do something else. So underscore tells the compiler that I don't really care about the value. Don't assign it to anything, just throw it away, I don't need it. But it makes it very clear in this case here that, oh, okay, so you do know that there's something coming back, but you really don't care. So you're telling anybody coming after you and looking at your code that, okay, the developer who built this or wrote this knows that there's information coming back, but it's not needed. We can ignore that stuff. Very simple. So it's more of an intent thing for this scenario. It's like, okay, so what was the intent? Well, I ignored it. But you've also got this thing here. This is another example. So in this case, we've got do something which is void. It's not an async method. And it calls do something else, which is an async method. But what I want to do in do something is I just want to call do something else fire forget. It could be like, hey, log this thing. I don't care if you succeed or not. I don't want to wait for you. Just go and do that in the background. Let me keep going on with my stuff. If that works out, fine. If it doesn't work out, I really don't care. Just it's not very important. If you write this code that I've got here, which is do something, calling do something else, and just ignoring the fact that it's async, you're going to get a warning. And I'm not saying that warnings are necessarily something you have to care about. They're just warnings. Literally, they tell you that, hey, you might want to have a look here because there might be something wrong. But they're kind of annoying. It's kind of nice to get rid of them so that you sort of, okay, so I know that I've checked all of these things. So once again, with that warning here that says, because this call is not awaited, execution of the current method continues before the call is completed, blah, blah, blah. So it tells us that you probably want to have an await here. But then I don't really want to wait because I want to do a fire or forget. Go and do that thing. I don't care, fail or whatever, just go and do it. So here, by adding that discard that I was talking about, it means that I'm not really just telling the future developer, the future me, when I come back to my code that, hey, I know what I'm doing here, I don't care. By adding this discard here, I am saying that I know that there's a task coming back, I just don't care about the task. And now you've shown your intent to the compiler. So now the compiler removes the warning because, okay, you figured it out, you're getting the task back, you're not awaiting it, I really don't care, but you've at least shown me that you don't care about the task being returned, so it becomes fire or forget without the warning. Sweet. But it can also be used for another one. This is actually a real favorite of mine. I assume that loads of you listening or looking at this feed here has written this code here. So it's a do stuff method, and it starts out with if it's null, throw argument null exception. If it's less than, that's interesting. That should have been less than 1. Anyhow, throw an argument exception. But anyhow, there's all of these checks that we do before we start our method to verify that the incoming values are correct. And right now, it's just one incoming parameter. It's just one string name. I have to check it for null, and I have to check it for length, which I apparently don't know how to do. And it becomes, well, in this case, there's 6 lines of code with a space, so 7 lines of code just to verify those 2 things. And if I'd had more incoming parameters, I might have had to check more of them. And we end up with this massive block at the top going, throw argument null exception, throw this, throw that, because you're a moron calling the method with the wrong arguments. With discards, we can do this. This is lovely, in my opinion, because it basically means that, hey, I want to do make an expression here, so I'm going to check to see if the name, and then question mark means if it's not null, if it's null, then do whatever is on the right hand side. So if name is null, then throw a new argument exception. But that syntax there, name, question mark, blah, is actually an assignment that allows us to assign name or something else if it's null to a variable. But the discard here allows us to basically say, it becomes that the syntactical thing is I am assigning something, but it's actually not an assignment because the right-hand side is a throw. And also whatever it could have assigned, I really don't care. So we end up with these much neater little one-liners for all of this. Is it null? Is it valid? Is it this? Is it that? So all of our checks can become a lot more dense, and we don't have to start our functions with 70 lines of curly braces and if statements and all of that. It just becomes one thing. And this also includes another C# feature which didn't get its own slot, but it got showed anyway. It's C# 7's version of throw expressions. So it allows us to throw things as part of an expression, which wasn't allowed until C# 7. So the combination of discards and throw expressions allows us to do this nice, simple variable validation. Very sweet, very cool, makes our code much nicer. At number 5, we've got actually, okay, so I'm cheating a little bit. At number 5, I've actually taken 2 features and pulled them into one and called them number 1 because they both have to do with null stuff. So we've got null-conditional operators and we've got null-coalescing assignment. I thought they were close enough to call them one thing. So we're going to start off with null-conditional operator, which is quite nice. So look at this code here. Send order confirmation, right? So send order confirmation, it takes in an order, and I have to verify that the order isn't null. And if the order isn't null, I need to verify that the order actually has a recipient, so it's not null. And then if it has a recipient, I need to verify that the recipient has an email address. And then once I know all of those things, I can then call send email to and use the email address from the email address on the recipient on the order. That becomes an ugly mess, to be perfectly honest. You can see that cone-shaped things with ifs inside ifs with inside ifs, which is just annoying. And then, okay, sure, absolutely, this is worst case scenario. I could make it nicer. I could do it in one if statement, which is a little bit better, a little easier to read. It's not ugly with all the curly braces and the little cone of death going to the right. But there's still a lot of checks going on. I have to do 3 checks in here to verify that I can find whatever I need to be able to send an email. So in C#6, they introduced the null coalescing thing. And what that does, it looks like this. So it allows us to basically dot through our properties, but we use what's called the Elvis operator. So it's the question mark dot. So question mark dot says, if order is null, then the whole statement becomes null. If order is assigned and it's not null, then go and look at recipient. If recipient is null, then the whole thing becomes null. Otherwise, it goes and looks at the email address. And then if the email address is null, it becomes null. Otherwise, it becomes not null. So we can do all of those multiple lines of this stuff here can get turned into a one-liner, which is very, very easy to read. All we do is we take whatever we need, and then we add a question mark for every step that we do that can be null, and then we check for a null at the end. So we can do sort of a null evaluation over a graph of objects. And I said wrong. It's not null coalescing, a null-conditional operator it's called. The last one is in this thing here is null-coalescing assignment. So the previous was an operator where we could look at things. The null-coalescing assignment is once again, is null-based, but it's a different feature. But once again, it tries to make our code denser, nicer, easier to read. So for example, this code here, you get my options passed in this case. And then the first thing we do, we check to see if options is null. And if it is, in this case, we're not throwing anything. Instead, we're saying, hey, if it's null, then I want you to use the defaults instead. So it's okay to pass in null. I'll just replace it with default values if it is null. And in C#8, we get this really cool null coalescing operator that allows us to say, if the previous, if the value is null, then assign it to this. Otherwise, keep the value. So this thing here says that if options is null, then assign it to my options.default. Otherwise, keep options. So it's literally exactly the same as this. But once again, it becomes this one-liner, which is much easier to read. So it's a version of what I did before with the throw expression, where we do just question mark, question mark. So what you normally have would be options equals options, question mark, my options.default. But in this case, we get to shorten that down even further into just question mark equals. And then you can start adding questions about, are we really at the point where C# needs 3 character operators? Because we're at question mark equals. I used to like C# in the beginning because it was fairly simple. There were not a ton of features. And I agree the features are good, but we're also increasing the bar for learning this language. Now, as I said, we're looking at 3 character operators. And for most people who are new to development, they would look at this and go, oh, I don't understand. My head hurts. I want to go home. On the other hand, the other side of that coin is that you don't have to use these features. They are there, but the old syntax works just as well. It's just for us people who have been around C# for a long, long time, we can write this very nice, dense code that makes it easier to read our code as well. So that's kind of cool. I use these quite a lot. Actually, I use the first one. The second one with assignment is not something I use a whole lot, but it's a cool feature to have, and it makes our code a lot easier. And this is where we now move into number 4, null reference types. So nullable reference types is a bigger feature, and it's really cool, and it's there to help us. And what it does is we come back to this, right? So we have this print length, and the first thing we have to do is we need to check the value for nullability, and then throw an argument null exception if it's null, and then we can do our thing. So once again, we come back to these having to verify things, and especially around null, we really always have to validate, is this null? I've told you to pass in a string, but since it's string is a reference type, it means that when we pass it in, it can always be null. So any reference type can always be null, which is annoying because any reference type you get in, you should always do a null check. And I know that we as developers generally skip that step, which is fine in most cases because we know that our code won't have a null value there. But it's kind of annoying having to have this little gut feel about you feel a bit sort of like, oh, is this null? Do I need to have a null check here? Can this actually be null? Maybe it can, maybe it can't. I might as well throw in a check for it and all of that. So to solve that problem, C#8 introduces this new deal called null reference types. Nullable reference types. And nullable reference types means that we can do this instead. We can go ahead and we can remove the null check because nullable reference types means that reference types has to be explicitly set up as nullable. So any reference type with nullable reference types becomes a non-nullable object. So you cannot have a null value of a reference type, which means that if we, in our function, require you to pass in a string, the compiler will actually force you to pass in a verified string and not something that can be null. So it also means that to be able to pass in, use a null value for a reference type, you actually need to set a question mark. So string question mark value equals null. So in nullable reference type, this is saying that, okay, so string is a reference type, but I'm using nullable reference types, which means that it can't be null. I have to explicitly make this nullable. So I do that. I declare it as a nullable. I set it to null, and I pass it into my print length, and I compile it, and the compiler is happy-go-lucky. It doesn't say anything, and I run my code, and it goes object reference set, not set to an object. But Chris, well, what? You said nullable reference types, and you're now showing us null reference exceptions. Yes, the code that I just showed you with the print length and nullable string and all of that is code that is running in a .NET Core application, and it just works. Because nullable reference types is something that you have to turn on. It's not enabled by default because it's a massive breaking change. If you turn it on an old project, you'll get like 10,000 errors in your code, and you're going to have to go walk through it and figure it out in every single place because it will break everything. So you actually have to go in and enable it. So you go into your CS proj file, and for .NET Core, .NET Framework-based applications or the new project system, you go in and you just add this nullable enable, and you're good to go. And if you're on the older project format, you go in and you add, you have to upgrade the language version to version 8 as a minimum, and you turn on nullable. Once you've made that change in your project CS proj file, you're telling the compiler that I want to opt in to nullable reference types. Once you've done that little config change, there's no change whatsoever in your print length method. And if I don't make any changes here at this point either, so I leave the value to be a nullable string and set it to null, if I build this now, I get a warning. I get a possible null reference argument. So basically the compiler is telling me you're potentially passing in a null value here. I have a warning for you. So that's kind of cool. So you can turn this on in an old project, and then you can see how many thousands of weird null issues you have. And then you can slowly walk through them and try to fix them, because it means that we never have to be afraid that something that we expect to have a value, a reference type being passed in, it will never be null, which removes a lot of weird null reference type exceptions and things like that. So it's a cool safety measure. And if you, for some reason, do need to have a nullable thing passed in, so you want to have a string that can be a null value, you just add that question mark. So question mark means, hey, it's nullable. You can pass in null here. That's fine. I will handle that on my own. I will make sure that I validate it for null when you pass it in. And we can then obviously combine that with this sweet null-coalescing thing where we go and look at value. If value is not null, then take length and use that. Otherwise, we do the question mark, empty string. So basically, we're safing up the nullable things, but we have to do it manually. But it's kind of cool because it means that we as developers have to take responsibility of whether or not it can be a nullable reference type. And if you know that your value is not null, but the compiler still says, hey, this is a possible null value, because there are scenarios that you can get variables that are not null, but the compiler can't figure it out. It does happen. Then you just add an exclamation mark to it. So you just go exclamation mark, hey, I know this value is not null. I've already checked it. This is fine. I'm going to trust this. I'm going to take responsibility. And then it's going to be happy-go-lucky and not complain about possible null reference. However, if we back up a few little things, I showed you this. So I turn on nullable reference type and I get a warning. And that's the thing. Nullability issues are just warnings. So they won't actually fail your build. So you can turn, as I said, you can turn it on in an old project. You'll give thousands of warnings, but they're only warnings. Your compile will still go through. But if you're going into a new project where you want to make sure that you use nullable reference types and you want to make sure that everybody sticks to it, you can actually go into your CS project file and you can set this thing that says warnings as errors, and then you say nullable. So by just adding nullable in there, it means that every warning that is part of the nullable spectrum, so basically there are a bunch of different warnings you can get, they all become errors. And then your nullability issues are now errors and they will fail your build. So if you turn this on at the beginning of your project, you can make sure that there's always proper null checks everywhere in your code, which is really neat. And if you're slowly converting a project, or maybe not slowly, quickly converting a project anyhow, and you want to you want to turn it on, but you want to disable it in some areas, you can use this pragma thing here and say nullable, enable, or disable, and then nullable restore. And then between those two nullable statements, it will check or not check your code. So if you turn on nullable reference types, you can then turn it off for a small part of your code, or the other way around. If you have it turned on, you can turn it off, you can turn it on for a part of your code. So you can slowly migrate your code into a nullable reference type scenario, even though you have stuff that's not working with that at the moment. So that's nullable reference types. It's a much bigger thing. At number 3, we have named tuples. This is another favorite of mine. I actually like this a lot. Because I'll get back to why. I believe a lot of us have written these classes, right? Stupid return value class. You have to create this stupid class that the only reason for you to have it is because you want to be able to return 2 values from a method. So in this case, I want to return a Boolean to say whether or not it was a success, and then I want to return a string for the response for whatever I did. And sure, I could use out parameters to do the same thing. And that was what you used to do in C# early days. But you cannot use out parameters with async methods, for example. So out parameters is not really a good way forward. So we end up writing these classes here, which are just annoying. And we try to reuse them as much as we can. And we make generic versions of them, but they're still there. So in C# 4, they introduced C# tuples. C# 4 tuples, or C# tuples, allows us to do this here, right? So we are allowed to do a function that returns, in this case, a Boolean and a string. And then we return a Boolean and a string, and we can return as many different values as we want, and we can return more than one value, and we don't have to have that stupid return class, which is cool. However, using that do something method, you end up with this. So you do something, response, and then response item 1, response item 2, with no explanation whatsoever what item 1 and item 2 is. So you end up, oh, wait, if you return, say, maybe 3 or 4 different things, maybe you shouldn't, but if you do, you have to go, oh, wait, 1 was that thing and 2 was that. And especially if you return a couple of different strings. So it's like, which string is which am I supposed to use, blah, blah, blah. I used it a little bit, and I think every time I try to use tuples, I go, I'm going to use tuples, they're awesome. And then you end up with item 1 and item 2, and it just fails, and I go back to the stupid return classes instead. So good try, didn't work. C# 7 introduces value tuples. And you can use C#7 value tuples for not just modern stuff, but if you're on .NET Framework less than 4.7, then there's a NuGet package for you to add them as well. So you can add them into your legacy code. C# value tuples are much cooler because they look kind of the same, but instead of saying just I'm going to return bool string, you actually give them a name. So you go, it's going to be a bool is success, and it's going to be a string response. And then you return it like you did before. You just do a parentheses with true and it works. And then when you call it, the compiler actually magically creates a response object for you, which has an is success and response property on it. So you get proper typing. You can go dot. It tells you what's being returned. It is awesome. C#4 version, the C# tuples are still around, and there are some big differences between them. So in C# tuples, they are immutable reference types with properties. So they are classes with properties that are read-only, they're immutable, but they're called item 1, 2, 3. Whereas value tuples are actually mutable. So they are value types, and they don't have properties, they have fields. So when you get something back as a value tuple, you can actually change it, which you couldn't do in C# tuples. But I don't care, they're awesome. They make a lot of code much, much simpler and smaller. And you can even go and do this, which is another cool feature in C# tuples, or sorry, value tuples, destruction. So that thing there is called deconstruction. And deconstruction allows us to take something that comes back from do something and split it out. So instead of getting a response object back, I can split the properties from that into different objects, or sorry, different variables. But then we end up with that blah, blah, bool, blah, that we had in the out variables before, or out parameters before, which is kind of annoying. So they also allow us to do this, where we basically declare our properties in the return. And yes, they are positional. So that it figures out per position what is being put where. And then you can use the individual variables instead. And you can even go and say var in front of it, and then var is success and response, and you get them typed automatically. And if you only care about one of the values, for example, is success, then you can just go and do a throw it away and say, hey, don't care about this thing here, just not my problem. I just want to know if it's a success or not. So that's kind of cool. Value tuples are awesome. They give a lot of flexibility to really small and nice code. And in C# 7.3, they were changed a little bit, so you actually get equality comparison. So if you create two tuples like this and value tuples and then compare them, that's going to work fine. Just a little thing to note is that your comparison is ordinal. So if you go and do that, it's actually going to go ahead and say, wait, it doesn't care if it's count and X and Y and product. It's going to be happy with the ordinal thing. So what it says is that int32 at position 1 equals int32 at position 1 of the other object, and string at position 2 equals string at position 2. So it's all positional, which makes it really, really dangerous in my world, because you can actually compare literally apples and bananas, which is bad. So that's value tuples, really cool feature. At number 2, we've got pattern matching and switch expressions. Another one of these, let's make our code smaller, simpler, easier to read. Not introducing anything new and spectacular, but it takes code like this and makes it simpler. So this code is almost valid. It's a log method. It takes an object, and then depending on what you're passing in, it will log it for you. So basically, it looks at the item. If it's null, it doesn't log anything. If it's a string, it converts the string to a string, the item to a string, and then compares to string.empty, and then writes out the string if it's not an empty string. And then if it's an iLoggable, it casts the item to iLoggable, and then based on the log level, it writes out errors. And then finally, at the end, if it's neither a string nor an iLoggable, it just writes out unknown and item. So that's fine. It works. But in C# 7, they've made this a little bit better. So in C#7, they introduced this cool idea where you can do an if statement and you can get with is. So you do if item is string, and then you can add a variable at the end of the if statement and say, hey, basically, or rather, if item is string, then assign the value to the str variable. So I don't need to do a separate cast afterwards, because normally you would have to do a check, say, if it's a string, then cast it to string, and then start working with the string. This combines that into one thing, and you can see it with the string, and you can see it with the iLoggable, that it basically, it does the evaluation and the assignment in one line, which makes it a little bit simpler. But we can also go ahead and do something like this. So with, sorry, we can go and do more interesting scenarios with this, because we can turn this whole thing into a switch, right? So instead of if, else, if, we can turn it into a switch that looks like this. So once again, null or empty string, do nothing. If it's a string, we can do case string str. And that means that if the item is a string, assign it to the str variable as a string. And then we can do iLoggable. Once again, if it is iLoggable, then turn it into add it to the loggable variable. And then we can combine that with when and say, so if what you're passing in is an iLoggable and the loggable log level is error, then do this. If the log level is that, do that. And if it's just if it's neither of those, go and do this thing over here, and then we can have a default at the end. So we can do this else if based on types and interfaces with limitations or filters on it in just one go, which is really nice. And we can also do my favorite, x is null. Instead of doing x equals null, x is null is readable. So that's awesome. It's a tiny thing, but it makes a difference. And also, it's not overridable. So if somebody goes in and overrides the equals operator, this is not affected, which is cool. C#8 allows us to do even more. It allows us to actually do an expression here where we do a function that returns the result of a switch. And in this case, you see here it takes the item, it does item switch to say, I want to do a switch on this thing. And then if it's null, then return empty string. If it's empty string, return empty string. If it's a string, return the string. If it's iLoggable with my filters on it, then return these things. Otherwise, return the message. Otherwise, unknown. So that whole massive if, then, else, blah, blah, blah turns into this really small, but it turns it into this, which is actually quite readable, even though it's doing a lot of stuff. And there are very few curly braces in there. We can also go and say iLoggable. So in this case, we know that it's being passed in as an iLoggable. And we can still switch on that. But when we do the switch, we can then use curly braces and say, hey, by the way, can you filter this based on the log level property? So instead of having to do like an if statement, if this, if that, whatever, we can go and actually switch based on properties inside of that thing in a very nice and nice way. And we can also combine that with actually taking in two parameters. So as you can see here, I'm taking in both item and area. And then I switch on the item. And then I use both the area and the item inside of my switch, which is kind of cool. Not to mention that you can make a really quick rock, paper, scissors by taking two input parameters, turning them into a tuple, and then you match based on both the values in the tuple. And then you can have a little sort of fallback for everything else with this throwaway at the end. And in C#9, they've taken it a bit further with things like this. So if we look at this piece of code here, the file name all, if you go in and look at the expression here, it's basically it says if x is, and then we can give and say, hey, it's going to be greater than or equal to a, or less than or equal to z, or, and then we can have another thing, and then we can have or. So we got very readable. If x is blah, 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 easy to read. And for the file extension here, once again, we can do a really nice length is greater than or equal to 2 and less than or equal to 4, which is once again very easy to read, which is nice. And they also introduced is not null, which is so much better than if x not equals null. Is not null is awesome. And the final thing, number one with a bullet, the biggest change in C# in the last few years is record types. And when I mention record types, some developers go, wait, we've got value types and reference types. Are we getting a new type of objects now? And no, we're not. It's not a new type of object at all. Records are actually immutable reference types with default implementations without you having to do a bunch of things. So basically, they will give you, the C# compiler will give you stuff for free. They will give you a very basic implementation. So imagine the order class here. It takes in an ID, article name, total, and has properties for each one of those. So we need to do boilerplate code here, 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 here. And then if you, after that boilerplate code, decide that, hey, let's do some equality checking as well, because we want to use order and compare them. So we need to add these methods in here as well with implementations. And all of a sudden, your very simple little class becomes this humongous thing, because all of a sudden there are all these overrides and properties and blah, blah, blah. But you really just wanted a basic class. You ended up having to do all of these things. So in C#9, they introduced records. So to do exactly that order class that I just showed you, all you have to do is this. Public record order, int ID, string, article name, decimal, total. That's it. And then the compiler will actually turn that into a class that has an ID property, an article name property, a decimal property. It will have a value comparison and all of that. So it means that we can do this. So we can just go ahead and we can create new orders. But the equals works fine because the equals overrides are already in place. So order 1 and 2 will not be equal. Order 2 and 3 will not be equal. But 1 and 3 will be, because they have the same ID. All the values are the same. So it basically compares all the values of your class. But it's not reference equals. They are two different classes. And also, toString is overridden as well. So if you do toString, it will actually tell you order and then the values within curly braces. There's just so little code for so much functionality, which is really, really cool. But then they've taken it even further with this feature here. This is very similar in code. I know it's a bit hard to read. But if we look at these things here, if we create one order, we can then say var order 2 should be order 1 with article name set to test2. That will basically clone order 1, but change the article name to test2. Or you can do with curly brace, and basically assign a copy of order 1 into order 3. So the two different references between 1 and 3, but they will contain the same value. So that with thing allows us to do immutable types in a very nice way. But they're just regular types, right? So we can still go and do what I'm doing in here. You can see I'm inheriting order, which is a record type. So I can inherit that. That's not a problem. I can add my own constructor in here and just call base, because in the end, my record is just a class, but it's generated by the constructor. I can add my own property to it, because I'm now taking responsibility of this class myself. I can add my own functions to it, because it's my own class. I'm just happening to inherit one of those auto-generated order classes that was created. So you get this really nice thing where you can do public record order, and you get all of that functionality out of the box from the compiler, but then you can take it further. You can make changes to it, and you can basically grow it up into its own class if you want to as well. So that was actually pretty much all I had about C#. I just want to mention one little thing. There is something I want to tell you, and that is these are my favorite features. My favorite features in no particular order. There are a lot of other features, and they are all dependent on what kind of software development you're doing. If you're into other areas, you might like other features and think my features are stupid. I don't care. It's up to everyone. It's very subjective. And I've also heard the question, is C# getting too complicated? I even highlighted that myself, that we might be getting to sort of is this too complicated scenario? We've got 3-character operators and so on. And yes, we're getting a lot of complex and cool stuff in C# that we can use, but it's always backwards compatible. So we can still use the old stuff. So new developers coming into C# is probably going to pick up some of the new features, but maybe use some of the old ones that are a bit easier to understand to begin with, instead of question mark equals. But I can also, and I can see us people have been involved in the business longer. We might pick up some features as well and keep old features, but they're both always available. So is it getting too complicated? Not really, because the old features are still there. Nothing is being removed. We're not forced into this new 3-character operator kind of C#. So is it complicated? Yes. Too complicated? No, because the old stuff is already there. It's still there. Other than that, I want to thank you for listening to me ranting about C# and the things I like about C#. You can reach me on Twitter at ZeroCall. And yeah, if you have any questions, feel free to reach out. I would actually expecting some people to come in and help out with the questions.
There we are.
Hey, I'm not alone. I'm feeling, they've left me. I'm now going to run all of .NET or JetBrains.NET days on my own, but apparently not.
The stream is still running.
Cool.
Also, I think both us and people in the comments are raving about your session. So thank you for a lot of good content. And actually, when I saw the Ace Ventura animated GIF, I had to think of something there. The ternary operator, I think from C#5 or 6 it was, I think the question mark colon is often referred to as the Elvis operator. And I think that's Null-Coalescing Assignment operator could actually be the Ace Ventura operator.
Ah, I like that idea. I think we should introduce that. Yeah. I think we should bring that in and make that a thing.
Let's do that from now on. Perfect.
Yeah, you've got weight in Rider. Can't you just get it into Rider somewhere? You should turn this into a...
It sounds like a good April Fool, I think, like giving all the different operators fancy names just for one day.
I think you should have it permanently. They need cooler names. Who can remember Null-Coalescing Operator or Null-Coalescing Assignment Operator? Ace Ventura Operator works fine for me. So are there any questions? Anybody actually have some input?
Let's go into those. By the way, people, if you have questions, ask them in the chat. We already noted a couple during the session, so let's maybe rewind to the beginning, default methods and interfaces. We had a question or someone asking about what if you're inheriting from 2 interfaces with different default implementations?
That's actually a very good question. I haven't looked at that. I assume that if you have 2 different... Actually, what happens in general if you have 2 different interfaces with the same method names? I think you're going to have to do an explicit implementation, and I think the default implementation is going to fall away. I don't think you can actually have that scenario. I think the compiler is going to kill you. I haven't looked.
That's something that actually many people complain about, because they think if you inherit the interface, then you can just call the method. But that's not true, because you have to make a cast on this with the interface, and then you can call the method. So it will always be explicit from the caller side, let's say.
Okay.
And otherwise it would be an overload if it's an inheritance chain or something. But yeah, usually you have to cast your own reference basically, and then call that method.
That makes a lot of sense.
There you go, blog post inspiration.
Yep.
There was actually also a question regarding multiple. I'm not sure where is it on our list here, but I will just say it anyways. With multiple default interface default methods, so you can kind of lose track. And some people were also concerned if it's a good idea to put implementation in an interface, you know, from a maintenance perspective. But I think, yeah. Go ahead.
I must say I agree with that. I don't think I see it as a last resort. Sort of, I have to introduce this, and I might introduce a breaking change. So it's sort of a fallback solution, in my opinion, or a potential way of doing extension methods kind of stuff. So instead of having an extension method on my interface with different implementations, like my example with the send email, if I want to have like a different pre-formatted email versions that all piggyback on the same implementation, then I think you can either do that as a default implementation of the interface or as extension methods. And I think having it on the interface keeps it in one place instead of having it in 2 places. But that's one scenario I can see that it works. Other than that, to me, it would be a last resort kind of a thing.
I actually have one more scenario that works pretty well, and that is, well, usually we don't have multiple inheritance, right? So we can only have one base class. And one place where I use that is in my pet project, let's say, where you can put things together like you would, like different components. And you just add them and they inherit those methods, and then you can use the original object, and actually it's used, it's called through reflection, so I don't have this cast, etc. This is actually a nice way. And also something that was surprising me is you can actually mark those methods as sealed still. So that would disallow the inheritor from overriding something. So it sometimes those features are quite surprising also, but they also ultimately fit nicely together, I have to say.
Well, that's the thing. I think we're going to see lots of interesting patterns coming out of this with these new features. Actually, earlier today, I just recorded a podcast where I was questioning the solid principles and said that solid principles might not be as relevant today, partly because, first of all, they're misinterpreted, but mostly because we have other languages, other compilers, other features, and I can see that we can do things today we couldn't before. And I think it's going to be the same thing with some of these features where people are going to invent new patterns that, for example, the null throw thing where you can check the null and throw at the same time is one of those patterns that I use it all the time now instead of the if statements. And I don't think that was what Mads Torgersen and his friends were thinking of when they came up with it, but it's one of those, hey, it makes a lot of sense to use it there.
Yes, speaking of new patterns that are emerging with using C# and all, I just want to mention this. Matthias and I obviously also follow the sessions, and I saw him just tweet while you were presenting about using deconstruction, switch expressions, and pattern matching and all of that in one tweet. So here goes. I think that's
during working hours.
Definitely a new pattern emerging there.
That's pretty cool. I can maybe explain it because I was during your session, Chris. I was quite often reminded about that, because previously that code down there, and it's not exactly easy to read right now because it's a bit small, but that has been several if statements before, you know, where you declare something, where you make the declaration first and then you assign it. And then first I had it with ternary operators, with one ternary operator nested basically. And that was a great moment because I didn't think of using switch expressions at that point, but then Ryder made me know and showed that little hint, and I could just convert, and that all combined with deconstruction. So I think after looking at this, I thought it's really nice. I mean, compared to what it would have been with previous C# versions, it's not comparable and quite nice.
I like that a lot. It takes a while to get used to because there's a lot of new stuff in that piece of code there. But to be perfectly honest, it's very succinct and very terse, but also very easy. Very easy to read might be an overstatement, but it's actually not that hard to read once you get used to it. I'm pretty sure if I showed this to a new C# developer, they're going to go, "Whoa, what kind of sorcery is this?" But this makes sense. I like it. It took me a little while to look at it, but I think we're gonna get used to that. We are going to get used to these new things. It just takes a while for our brains to get hardwired into that. Just look at how we've, at least me, I've started using LINQ, how we have changed in the way that we use LINQ. I remember teaching people about using LINQ, and you'd use that from blah, 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 the LINQ expression thingy. I never use that anymore now. I actually use the methods instead, but I can also read them in the same way that I would have that statement. So I think our brains sort of slowly wrap our heads around these new features, and things that we find complicated today is just going to be obvious in the future, maybe.
Yeah, very true, actually.
Actually, I also think some formatting might help. So for example, in that tweet, having some additional formatting so your brain can parse it more easy is probably better. A related question there, if you're speaking about expression-bodied members and all that, do you prefer to use the arrow on the first line or of the declaration line or on the next line? And in a class, do you mix regular bodies with expression bodies?
I do mix, but because expression bodies are just when it's a very, very simple method. So anything that becomes more than just more of a return or a concatenation or very, very simple stuff, I do regular methods. As for the arrow function, I put it on the first line. I put it on the same line. But if it's a more complex, long return, that ends up on the second line. So I think it's a sort of this is my function, arrow, and then new line. If I think that's the way I do it, or I don't know. This is a weird question, a hard question. I don't actually remember. Normally they're just on one line because they are very simple. If they're more complex, I still prefer the curly brace stuff. Also, what's the arrow thing called? Because I've heard different names of that. I've called it fat arrow, but apparently you're not allowed to say that anymore because it's body shaming. And I didn't actually know C# had a body, but it's now supposed to be called something else.
Well, I mean, we have the Elvis operator and the new Ace Ventura operator. So let's introduce something else.
I don't know what I would go for the arrow one, but yeah, the syntax is also kind of dependent on what team I'm on. Because if there's a strict policy of how they want to have it done, I'll do it in that way. I'm not too hard on that. I can do whatever. Anything else?
Let's have a quick
I lost track of our questions a bit.
Or that many questions.
I do have something to mention. It's a shameless plug for us. It's in our latest version of Writer and ReSharper. We have a great feature about named tuples. And little question there. Do you also use named tuples inside a single scope of the method?
Nope. Very rarely.
Same for me. Usually, it's mostly that I use named tuples when it leaves the scope, and it's called somewhere else. And otherwise, just either use deconstruction or something else. Yeah. But what I wanted to mention here is that named tuples can now be renamed in Writer and ReSharper. So that was a pretty cool introduction, I think, because otherwise, if you try to rename one, then usually all the declarations where it originates from will remain the same because they're not semantically coupled to each other. So you would end up having different names from, let's say, the method you called and how you use it in your own method, and that's pretty cool.
One thing you can add to Writer is copy paste with formatting into PowerPoint, because all of my slides are actually written. All the code is written in PowerPoint, and I've color coded everything to correspond to my theme in Visual Studio.
I actually think there's a plugin to do that.
Oh, there is, because it was kind of a pain. I can tell you, it's not as simple as it sounds.
I can imagine. Yeah, I know there's a plugin, and I even believe in some cases that Writer should do that manually, or at least for you, so you don't have to do it manually.
I might have to have a look at Writer. I must admit, I use VS Code mostly today, but Writer might be an option.
Cool. All right. Do we have any more questions coming in? Maybe one more around default interface methods. It's probably more theoretical or conceptual, but why would you not use an abstract class instead of default interface methods?
Well, once again, it comes back to kind of a fallback scenario in my case. If I have decided to do, it generally comes out that you already have an interface and you add something new to it in a lot of cases, and then you've already made the choice of having your interface instead of an abstract base class. Other than that, an abstract base class would do exactly the same thing for you. There's no difference whatsoever. It's just that people tend to lean towards interfaces more than abstract base classes in C# nowadays for different reasons. So it can, as I said, it kind of depends. If it's because you already have an interface, then it makes sense to do it instead of changing that into an abstract base class. If you start out from the beginning, then an abstract base class would probably do it for you as well. But you do lose, as Matthias mentioned, the idea of actually having almost like multiple inheritance by having features come in from different interfaces as well.
I have one more question. Chris, do you know what your last name means in German?
Smart.
Oh, yeah, I'm surprised.
I actually speak a bit of German.
That's cool.
I took German in school, and the name is German originally. Traveled through Denmark, so my dad is Danish, and I've also had relatives live in Germany, so I know a little bit. But I should have been named something else. If you're in the old days, you would be named after a trait of yours or what you worked with or whatever, and if in those days, I would not have been called that.
Do you know the scene? And for some reason, I always have to. It always reminds me of the scene with Homer Simpson where he dances in front of the fire and says he's smart.
Haven't seen it.
That's because they in that moment they also say I am so klug, but with a K at the end. So your way actually is the right way of writing it, like your last name. But yeah, always reminds me of that.
And then I combine it because my Twitter nick, Zero Call, is sort of a combination of English and Swedish and means no clue. So I sort of zero it out with last name Smart, Twitter nick, no clue. Puts me sort of in the middle, just average.
That's mind-blowing, actually.
It's very smart, yeah.
Except that nobody understands.
All right, let's maybe end with one last question, and I think that's a very nice bridge to bring our next speaker on. It's kind of a question / opinion, I guess. But the question was, do you agree that basically most important features in C# 6 to 9 have already existed in F# before? And do you prefer C# or F#? And when do you actually think the two languages will just be exactly the same?
It's a good question, and it's interesting because it seems like it was more of an opinion than a question. I assume the person is an F# person. I've never written anything in F#. I would counter it and say, haven't we seen all of the features in Lisp? So I think F# is just copying Lisp anyway. We've seen most of this, but perfectly honest, it feels like both F# and C# are just taking the best features of previous languages and kind of merging them together. F#, I don't have a strong opinion. I know it has some benefits. I'm just not a functional developer. C# has been what I've always done, and I don't know. We have a hard time. We have some F# developers at our office. We have a hard time to find clients that actually want to have F# because as a consultancy, we normally write code and then drop it off or help other developers build it. And there are so few F# projects in Sweden, to be perfectly honest, that we see. So haven't had time to look at it. But yeah, in the end, yes, C# is becoming way more F#-ish over time because we're taking a bunch of those features and making C# way more functional. And F# is picking up C# features and making it more object-oriented. So I think in the end, yeah, we're probably going to end up with a merged version of it that supports both things.
We'll need a new name for the language at that point.
Probably, yeah.
Yeah. All right. Thank you, Chris, for an amazing talk. Great questions and conversation. And let's maybe bring in our next speaker and ask them the same question as well. So, Chris, see you next time. Thanks again.
Thanks, guys. Bye.